Think about the distance, the gap between having an idea in your head and a machine actually executing it in the real world. Beat. That distance is shrinking. It is shrinking very fast.
Yeah, the friction of computing is just vanishing before our eyes. We are moving from giving instructions to just having intentions. It is a really exciting time.
Welcome to the deep dive. We are looking at the latest AI fire report today. We have a fascinating roadmap ahead of us. We are tracing the evolution of how we command AI.
Right, and it is a wild trajectory.
We will start with Anthropic's Claude Sonnet 5. It is acting autonomously on your desktop right now. Then we're going to look at the rapidly evolving ecosystem, the new hardware and software supporting these tools.
The plumbing underneath it all.
Exactly. And finally, we will explore Meta's new breakthrough. They are reading commands directly from your brain.
Which is just pure science fiction turning into reality. I am eager to unpack these mechanisms with you.
Let us start with Anthropic. They just officially released Claude Sonnet 5. The narrative here is a massive shift in utility. AI is moving away from being a passive chatbot.
Yeah, it is supposed to be an active, independent worker now.
But honestly, I am a bit skeptical of the framing. Anthropic is billing Sonnet 5 as their most agentic model. That word feels like a marketing buzzword lately. Are we just talking about a chatbot with a longer memory?
Well, that is a fair pushback. The term gets thrown around a lot, but agentic means capable of making decisions and acting on its own.
Right.
We are not just talking about memory here. Sonnet 5 is a massive leap forward in actual utility. It shows major structural improvements over Sonnet 4.6.
And the cost factor is huge, too.
Huge. We are seeing near-Opus level intelligence. But it comes at a fraction of the computing cost. It offers a highly efficient cost-to-performance ratio, especially when you compare it to their heavier Opus 4.8 model.
The economics are finally making sense for broad deployment. If it costs too much per action, companies will not use it. True AI automation is only viable if the math works out.
Right, and the math is finally working. But the capabilities are what actually justify the integration. Sonnet 5 can formulate multi-step, long-term plans. Yeah, it keeps track of completed steps while monitoring pending ones. It autonomously opens and uses tools like web browsers, and it does this with minimal human oversight.
So it actually corrects its own mistakes if a web page fails to load.
Exactly. It just tries a different path.
So it is positioned as a reliable backbone for complex tasks. You can use it for multi-step software engineering. You can deploy it for automated data auditing.
You can build customer-facing agents that actually resolve problems. It allows teams to automate dense, frustrating desktop tasks, like navigating through multiple browser tabs to find specific data points.
Previously, you needed larger, cost-prohibitive models to handle that logic.
Right. Now you can do it efficiently at scale.
There was also a major security update I noticed. It introduces real-time cybersecurity safeguards for these autonomous actions.
Yeah, that is a critical feature.
It cleanly refuses high-risk or malicious requests. And it does this without throwing standard error codes. Why is avoiding an error code such a big deal?
Because standard error codes are basically roadmaps for hackers. If a system crashes and spits out an error log...
It reveals vulnerabilities.
Exactly. It tells the attacker exactly what part of the system broke. Sonnet 5 handles malicious inputs elegantly without crashing the workflow.
It just politely and cleanly steps around the threat.
That stability is absolutely essential for enterprise adoption.
But there is a technical quirk in the report. Sonnet 5 runs with something called adaptive thinking. It is turned on by default, though you can toggle it off. But leaving it on results in a significant computational trade-off. Why does this new model eat up 30% more tokens just to give the same answer?
Well, that is the core of how it solves complex problems. Adaptive thinking means the AI generates hidden intermediate steps. It is reasoning through the problem in the background.
Like mapping out a logic tree.
Yes. It maps out the logic tree before it finalizes the output. That invisible internal work requires processing power. It requires more tokens to generate that hidden chain of thought.
So it's basically thinking out loud before it actually answers you.
That is exactly what it is doing. It drafts a plan before it speaks. It takes a moment to reflect on its own logic.
Which is very human, really.
It is. Yep. That extra compute leads to much higher quality answers. It reduces hallucinations significantly because it checks its own work.
It is fascinating to watch this unfold. The models are getting incredibly smart. But Sonnet 5, acting as an autonomous worker, exposes a vulnerability.
The infrastructure, right?
Yeah, we do not have the infrastructure to support this. The rest of the tech world has to adapt to run these agents.
The ecosystem is desperately trying to catch up. The models evolve faster than the environments needed to house them.
AWS just launched a massive initiative to address this. They created a $1 billion FDE org. That stands for Forward Deployed Engineering. But what does that actually look like in practice?
It means sending elite tech squads into non-tech companies. AWS is embedding AI engineers directly inside these enterprise clients. They want to help them deploy AI agents faster.
Because the bottleneck is no longer the intelligence of the models.
No, the bottleneck is the integration. Companies have access to Sonnet 5, but they lack the plumbing.
They have the tools, but their internal data is a mess.
It is siloed, unstructured, and inaccessible to an AI agent. AWS is stepping in to build that necessary plumbing. They are basically stacking Lego blocks of data for these companies.
They are standardizing it so the agents can actually read it.
Precisely.
And the hardware layer is shifting dramatically, too. We are seeing massive financial investments in specialized silicon. Etched is an AI chip startup making huge waves.
They are being called a legitimate NVIDIA rival right now.
They just hit a staggering $5 billion valuation. And they booked $1 billion in chip orders. But how can a startup like Etched possibly rival NVIDIA? NVIDIA essentially owns the entire AI hardware market.
Well, Etched is not trying to train new AI models. NVIDIA GPUs are generalists designed to do massive, complex math. They read the whole internet to train a model from scratch.
Right, which takes massive data center.
Exactly. Etched chips are built specifically and only for inference. Inference is just running the models after they are already built.
The day-to-day operations.
Yes. Training is a one-time massive cost, but inference is where all the long-term energy and money is spent.
Got it. They optimize for running the models, not training them from scratch.
It is a highly specialized, hardwired approach. Etched is burning the actual AI architecture directly into the silicon. Because it is hardwired just to run them, it operates differently.
It strips away all the unnecessary generalist functions.
Right. It aims to make inference significantly faster. It makes running agents cheaper and vastly more power efficient. They are completely moving away from today's power-hungry GPU setups.
We are also seeing the software interfaces adapt to this reality. Cursor is a highly popular AI-assisted code editor. It is now available as a native iOS app.
And it is currently in public beta. That completely changes the dynamic of software development.
Because you can build and deploy from anywhere now.
You can control complex AI agents directly from your phone.
Think about what that means for a moment. Beat. You are waiting for a train, you pull out your iPhone, and you are orchestrating a fleet of AI software engineers.
It is wild. The barrier to entry for building software is dropping to zero. And Google is moving aggressively in this space, too. Google Gemini Spark just rolled out massive updates.
They launched a dedicated macOS app for seamless desktop integration.
They added direct Canva and Dropbox connections to its workflow. And they added MCP support.
We should clarify what MCP actually is.
It stands for Model Context Protocol. It basically gives standardized hooks to talk to your local files.
So it lets the model securely reach into your local apps.
Yes. Real-time alerts are now part of that workflow. The tools are finally meeting us where we already work.
There is also a strange economic side effect to all this power. The AI Fire report highlights a crazy global story. There is a massive gray market for Claude access right now.
The arbitrage happening behind the scenes is unbelievable. Demand for top-tier intelligence is heavily outpacing legitimate supply.
Chinese developers are reportedly buying Claude access on this gray market. They are paying only 5 to 10% of the official price. How does that economic loophole even exist?
Well, they are exploiting regional pricing differences and pooled accounts. They use various masking methods to hide their real identities.
They effectively mask the end user's location from Anthropic.
Yeah. It highlights how desperate the global demand truly is. Access to raw intelligence is becoming a critical global resource. People will find back doors if they are geographically restricted.
With all this capability, I still find myself frustrated sometimes. I still wrestle with AI just agreeing with everything I say. It is a genuine roadblock for real brainstorming.
It is a widely documented problem called sycophancy. These models are heavily trained to be polite and helpful.
But sometimes they think being helpful just means nodding along.
Exactly. They mirror your assumptions instead of challenging them.
The newsletter has a great prompting tip for this issue. You just add one extra rule to your initial prompt. You tell the AI, always suggest a better alternative.
It is such a simple, elegant, mechanical fix. It forces the model out of its passive, agreeable state. It demands critical thinking and structural pushback.
It fundamentally changes the dynamic of the conversation.
It really does. There is another weird quirk to watch out for, though. We are seeing a new tell for AI-generated writing. It is the sudden rise of fake, profound statements.
Oh, absolutely. Sentences that sound incredibly deep on the first read, but when you really analyze them, they say almost nothing.
They are basically word salad.
The report suggests aggressively rephrasing these structures before you post them. AI models love to summarize paragraphs with these grand, sweeping generalizations.
They wrap up thoughts with overly poetic, hollow conclusions. They perfectly mimic the cadence of human insight.
They have the rhythm of a profound thought.
But they lack the actual soul and specificity of it. You always have to be the final editor of these outputs.
1 through 2 sec silence.
Right.
We just talked about controlling autonomous agents from your iPhone. We talked about Cursor and Gemini, streamlining our workflows. But what if you did not even need your hands? Let us talk about the ultimate interface.
This is where things get truly science fiction. We are preparing to move beyond screens and keyboards entirely.
Meta just introduced version 2 of their Brain2Qwerty project. It is a non-invasive brain-computer interface.
A BCI. And it decodes live brain scans into full, readable sentences.
And we have to emphasize the word non-invasive here.
Right. This is external hardware sitting on your head. There is no surgery required for this to work.
The research methodology for this project was incredibly intense. 9 volunteers spent 10 solid hours inside a non-invasive brain scanner.
Just typing text normally.
But the system mapped their neural responses the entire time.
10 hours is a grueling amount of time in an MRI-style scanner. But that intensive, prolonged tracking paid off massively. They produced a clean data set of nearly 22,000 completed sentences.
The results are what stopped me in my tracks today. Whoa, 61% average accuracy without a single surgical implant.
It is a massive paradigm-shifting breakthrough. The highest performing volunteer in the study actually hit 78% accuracy.
To give that some context, we need to look at previous attempts. Competing non-invasive systems usually peak at around 8% accuracy. Going from 8% to 61% changes everything.
It completely shifts the landscape of human-computer interaction. Most high-accuracy BCIs currently rely on deep surgical implants.
Think about companies like Neuralink drilling into the skull.
That presents a massive physical barrier to widespread everyday use. Most people are never going to opt for elective brain surgery.
But an external scanner, a headset you just slip on, that is a completely different story. It opens up accessible communication tools for millions of people.
It democratizes the technology.
But I want to understand the mechanics of how it actually works. The architecture uses 2 different AI models working together. Why is a second AI model needed just to add semantic meaning?
Because non-invasive brain signals are incredibly noisy and blurry. The electrical signals have to travel through the human skull.
The bone scatters and muffles the neural data significantly.
Right. The first model just tries to read that messy electrical noise. The second model acts like an advanced predictive autocorrect. It predicts the most logical word based on the surrounding context.
It smooths out that messy, raw neural data into coherent language.
Exactly.
I am trying to picture this mechanically. It sounds like trying to listen to a conversation through a thick wall.
That is a brilliant way to look at it.
So the first hears the neural noise, and the second guesses the actual meaning.
Precisely. It uses linguistic context to bridge the physical gap. The first model hears muffled vibrations through that thick wall. It might sound vaguely like "pass the salt."
But it is slightly garbled and unclear.
The second model knows you are sitting at a dinner table. It directs the output based on environmental and conversational probability.
Meta did something very interesting with this research. They did not lock it behind a proprietary corporate wall. They open-sourced both the data sets and the underlying code.
They did this for both versions of the system they built.
That is a classic meta strategy in the AI space right now.
They want to commoditize the fundamental research layer. By opening it up, outside development teams can openly build on it. Researchers globally can test and refine the framework.
It dramatically accelerates the entire field of non-invasive BCI development.
It means we're going to see rapid compounding iteration. Other university labs will take this 61% baseline. They will tweak the models and push it much higher.
When you crowdsource the optimization to the global scientific community, breakthroughs happen at a much faster rate.
We could realistically see 80 or 90% accuracy in a few years.
Beat. Let us synthesize what we have covered today. Let us connect these dots for you.
Yeah, let's step back and look at the larger structural shift.
We are watching the friction of computing disappear in real time. We have AI agents like Sonnet 5 acting autonomously. They can now reason through hidden intermediate steps.
They can browse the web on their own to solve problems. They can execute complex, multi-step engineering tasks safely.
And the broader ecosystem is adapting to make that seamless. AWS is building the internal plumbing for massive enterprise integration.
We have mobile apps like Cursor to control these agents from anywhere. We have dedicated, hardwired silicon from Etched, making it cheaper to run them.
The infrastructure for an automated world is being laid down rapidly.
Mm-hmm.
And then you look out just a few years into the future. With Meta's non-invasive BCI, the physical interface itself disappears entirely.
We might just be thinking our commands directly to these autonomous agents.
The distance between human intent and machine execution is collapsing rapidly. We are moving from typing on keyboards to swiping on glass screens.
And soon we will just be broadcasting our intentions.
It is a profound shift in how we interact with our environment. It changes the fundamental definition of human labor. It changes the biological constraints of human communication.
It really does. It removes the physical barriers that have defined computing for decades.
I want to leave you with a philosophical question to ponder today. Think about that shrinking distance we talked about at the beginning. If an open-source, non-invasive brain scanner eventually reaches 99% accuracy, will the act of speaking out loud or typing on a keyboard eventually feel as quaint and outdated as writing a letter in cursive?
It is wild to think about.
2-sec silence. Thank you for taking the deep dive with us today. We will see you next time.